we're going to begin our review video for section 9.3. That's chapter 9, section 3. And as always, we always start our learning videos with the learning target for the day. Today we're going to learn to represent linear functions using function tables and graphs. One new vocabulary term. It's called a linear function. A linear function is a function in which the graph of the solutions form a line with all the points in between. Let's jump right into some practice problems here. During a clearance sale, a music store is selling CDs for $3 and tapes for $1. Graph the functions of 3x plus y equals 6 to find out how many CDs and tapes Bill can buy with his $6. Well, before I can graph them, I need to pick some values for x. I need to find some values, find the corresponding values of the answers for y, which will give me my ordered pair. I'm going to look at this equation, and I'm going to rearrange the equation so that it has y on one side of the equal sign all by itself. I'm going to do that by saying 3x plus y is equal to 6. I'm going to subtract 3x from both sides. That will cancel these out, leaving y is equal to a negative 3x plus 6. Now I'm going to pick some values for x, discover or find their corresponding values for y, and actually plot the ordered pairs. So I'm going to pick 0 for x, I'm going to pick 1 for x, I'm going to pick 2 for x, and I'm going to find their corresponding values of y by plugging those values in for x. If I plug in 0, I get a negative 3 times 0 plus 6. Negative 3 times 0 is 0, so I could buy 6 tapes. If I plug in 1, I've got 1 times negative 3 would be negative 3 plus 6 would be 3, so I could buy 3 tapes. If I plug in 2, 2 times negative 3 is negative 6. Negative 6 plus 6 is 0. So I'm going to graph those 3 points, and I'll do this on this graph over here. So I've got x and y, I've got the point 0, comma 6, I've got the point 1, comma 3, and I've got the point 2, comma 0. So 0, 6, so 0 and 6, 1, 2, 3, 4, 5, and up here would be number 6. I've got 1 and 3, 1, 1, 2, and 3, and then I've got the point 2 and 0, 1, 2, and 0. Those 3 points represent the ordered pairs that make it true, make this equation true or this function true. So I could buy 0 CDs and 6 tapes, or I could buy 1 CD and 3 tapes, or I could buy 2 CDs and 0 tapes. All right. Moving on to next problem here. They're asking me to graph the equation y is equal to x minus 3. All right, so I'm going to say, I'm going to again set up my ordered pairs, x and y. This is already in the correct form for us for finding y. I'm going to pick some values of x and y. I'm going to say let's do minus 1, let's do 0, let's do 1, and maybe 2. We'll do those 4 points and see how they line up. I plug 1 in here, so I've got negative 1 minus 3. Negative 1 minus 3 is negative 4. I do 0. 0 minus 3 is negative 3. I do 1 minus 3 is negative 2. And I do 2 minus 3 is negative 1. All right, so I'm going to plot those ordered pairs on my graph. I've got negative 1 is for my x, and I've got negative 4, 1, 2, 3, 4. So that's my first ordered pair. The next one is 0 and negative 3. 0, 1, 2, 3 in the negative direction. I've got 1 and negative 2. Here's 1 and negative 2. And I've got 2 and negative 1. Well, if I connect all of those in a straight line, that straight line represents then all the values that would make this a true statement, all the values that would make the original equation or the original function y is equal to x minus 3 true. They're asking us to graph y is equal to x minus 2. And actually, they're asking us which one of these graphs is correct. I'm going to do a little bit of searching for ordered pairs. I'm going to say x, y. I'm going to pick some values of x and find corresponding values of y to see which one works. I'm going to use the numbers, say 0. Well, it's 0, negative 1, and positive 1. Let's 0, negative 1, and positive 1. That may give us enough information. If I plug 0 in for x, I'm going to get negative 2 for y. If I plug negative 1 in for x, negative 1 in for x, I'm going to get negative 3. And if I plug 1 in, 1 minus 2 becomes negative 1. Let's plot those graphs or check which one of these graphs to see which one works. If I try 0, negative 2 on this graph, 0, negative 2, well, that might work. We'll find out. We've got to check them all. Negative 1, negative 3. Negative 1 for the x becomes negative 3. Doesn't look like it works. All right, so it cannot be A. Let's go to B. Let's go 0, negative 2. 0, 1, 2. All right. Let's go negative 1, negative 3. 1, 2, 3. Again, not looking like it's working on this graph, but we'll try 1 and negative 1. None of those fall on that line, so it can't be B. Well, if you look at the 3 dots here that we've got plotted, you can see that they all lie down in this part of the graph, so it can't be letter C. Also, let's try D. We've got the first one is 0 and negative 2. That falls on the line. We've got negative 1, negative 3, negative 1. Down negative 3, 1, 2, 3. That one falls on the line. And we've got 1, negative 1. That one also falls on the line. So D is our correct graph for this function or this equation. Number 6, here it says, which line graph below best represents the table x and y? Well, again, we have to go through and check. Let's see which one of these has the point 0, 1 on it. If we go 0 for the x and positive 1, 0 is here, positive 1 would be right there. So A is not going to work. If 1 point fails, they all do. We'll try B, 0 and 1. Well, possibly B is going to work. Let's try 1 and 3. B fails. All right. If we went 2 and 5, 1, 2, 3, 4, 5, and we go one more, 3 and 7, 1, 2, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. You can see that we're getting further and further away from our correct answer. So it's not going to be B. If you look at how steep this line is and compare it to this line, you can see that doesn't work. And also this fails our very first trial, which is 0, 1. So it cannot be C. We'll try D one more time, see if that works. 0, 1 falls on the line. If we go up 2, we go 1 and 3, 1, 1, 2, 3. That also falls on the line. We can try 3 and, I'm sorry, 2 and 5, 1, 2, sorry, 1, 2, 1, 2, 3, 4, 5. That one falls on the line. Check the last one just to be sure. 1, 2, 3 on the x-axis. 1, 2, 3, 4, 5, 6, 7. All of those, the correct answer is D. Correct answer is D. All right, we've got another one. But here, which line graph below best represents the values, the tables for the ordered pairs x and y? As I look at these, I'm going to check the ordered pairs 0, 3. So if I look at this one, 0 and 3, 1, 2, 3, A fails on that first point. If I look at B, 0 and 3, 1, 2, 3, well, that's pretty close. We better keep checking. If I try 1 and 0, that checks out. If I try 2, 1, 2, and negative 5, 1, 2, 3, 4, 5, that one seems to fail. And let's go 3 and 6 goes off our graph. Let's look at letter C here. So I'm thinking B is not going to be, it's close, but it's not going to work. If we look at the first one, 1 and 3, 1, 2, 3, works for the first point. 1 and 0, well, it doesn't work for the second point, so it can't be that one. If I try letter D here, or graph D, 0 and 3, 1, 2, 3, D doesn't work. B is our best answer, even though it does appear that there's some graphing irregularities there.